When a number is written as another number greater than or equal to 1 but less than 10 times an integral power of 10, that number is said to be written in scientific notation. And here's an example. 9.3 times 10 to the 7th. The 9.3 is greater than or equal to 1, but it's less than 10. And the 10 to the 7th power is an integral power of 10 because 7 is an integer. The 9.3 is called the mantissa, and the 7 is called the characteristic. When we multiply it out, we get 93 million, which happens to be an approximation often used to represent the number of miles that the Earth is from the Sun. Let's try to figure this out without using a calculator. We start with 9.3, we're multiplying by 10 to the 7th. Well, you probably already know that if it was 93 times 10 to the 7th, you'd simply add 7 zeros. You look at the exponent, the 7, it's the key. But since it's 9.3 instead of 93, instead of simply adding 7 zeros, what we're really doing is moving the decimal 7 places. So we've already moved it 1 to get it around the 3, 2, 3, 4, 5, 6, and 7, and then I add in zeros as necessary, which you can see requires 6 more to get that decimal moved from 9.3 to where it belongs in 93 million. And of course, in 93 million, since there are no significant places to the right of the decimal point, the decimal does not even have to appear in the number. Here's another number. This is often used to represent the number of feet that light can travel in a second. 186,000. And what we're going to do with this number is start with 186,000 and convert it into scientific notation. Well, we know that in scientific notation, we want the decimal to go between the 1 and the 8, so we end up with a number that's greater than or equal to 1 but less than 10. So that's where the decimal is going to end up. And then we have to remind ourselves where the decimal was in the original number. Well, it was to the far right. Of course, you can't see it. We don't need to write the decimal in 186,000. But when we start to count to find how many moves from the original decimal to where we're going to place it, we start on the far right. There's 1 move, 2 moves, 3, 4, and 5. So it's going to take 5 moves to get from the far right in 186,000 to between the 1 and the 8 in 1.86. So now we write 1.86 times 10 to the 5th power because we moved that decimal 5 places. The number at the bottom is said to be written in scientific notation. Here's a very small number. Very small numbers can also be written in scientific notation. For this one, we're going to want the mantissa to be 1.32. Well, now we can see both decimal points, the one in the original number and where it's going to be when we put it in scientific notation. And our job is to find out how many places are in between those 2 decimal points. So let's count. We make some marks as shown, and then we count them up, and I count 9. So we're going to have to move the decimal point 9 places. And our mantissa is 1.32, but of course this is 9 places in the opposite direction from when we were putting large numbers in scientific notation. So of course, for small numbers, it's a negative exponent. 1.32 times 10 to the negative 9th. And now let's take a very small number that's already written in scientific notation, and let's see if we can write it in its original form. We write the 4.213 way over on the right because we know it's a small number and we're going to need zeros on the left side. We start our first move, but of course the exponent is negative 11, so we're going to need 10 more moves, and there they are. Now we're going to count to make sure we've made 11 total moves. We put in the new decimal point, we fill in the zeros, and it's customary then to write 1 more 0 on the left side of the decimal, not required but customary, the one with the blue arrow, and there's our number. It's a decimal point, 10 zeros, and then 4213, a very small number. At the top it's in scientific notation, and at the bottom it's written in what's called standard decimal form. Once again, if a number x is written as a number n such that 1 is less than or equal to n, which is less than 10, multiplied by an integral power of 10, then the number x is written in scientific notation. It is used for both very large and very small numbers.